Now, not all logarithmic functions are going to stay right there in the middle where they normally would be. Sometimes they're going to be shifted. So let's talk about horizontal shifts. So graphing a horizontal shift of f of x equals log base b of x. For any constant c, the function f of x equals log base b of x plus c. It shifts the parent function y equals log base b of x left c units if c is greater than 0, and it goes right c units if c is less than 0, and has the vertical asymptote of x equals negative c. The domain will change to negative c to infinity, and the range is negative infinity to infinity. So in this first case, we have a c that is positive. So we can see that everything is shifted over to the left. Here we have an x minus c, so sorry, an x plus c and x minus c. And so I guess we're assuming c is positive in both cases. But in the second case, it shifts it to the right by c units. So how to graph the logarithmic function of the form f of x equals log base b of x plus c. Identify the horizontal shift. So if c is positive, it goes to the left. If it's negative, it goes to the right. I know that seems backwards, but that's how it is. That's how it's been. Draw the vertical asymptote, x equals negative c. Identify 3 key points from the parent function, so you can shift over those key points, like it would have gone through 1, 0, but now you can move that over. And you could also do it would have gone through b1, but you can move that over either direction. Find new coordinates for the shifted functions by subtracting c from the x coordinate, and label the 3 points. The domain is negative c to infinity, and the range is negative infinity to infinity, and the vertical asymptote is x equals negative c. So let's sketch this graph. F of x equals log base 3, of x minus 2, alongside its parent function. So the parent function we would look at is, so we'd have those points we just talked about. It'd be 1, 0. I guess I should pick some colors. I'm going to pick blue for the original. Okay, so 1, 0. And then it would be 3, 1. This log base 3. Log base 3 of 3 is 1. And we could also go back and say like 1/3. Log base 3 of 1/3 is negative 1. So I'm just saying log base 3 of 1/3 is negative 1. So 1/3 comma negative 1 is a point. And then we'd have the vertical asymptote here. This is the original function. This is not the shifted function. And so we get a curve something like this. Kind of badly hand drawn. Okay. So now we're going to shift it. So it's x minus 2. So we go 2 units to the right. So I'm going to change colors here to green. So this 1/3 negative 1 is over 2 units here to 2 1/3 negative 1. And then we have 1, 0 is going to be 2 units over to 3, 0. And then 3, 1 is going to be 2 units over to 5, 1. And our asymptote, I'm going to change that to an orange asymptote, is going to be negative or positive 2. So you got to do the sound effects when you're doing this. And it comes up like this. So our domain for the new function is going to be positive 2. Positive 2 to infinity. The range didn't change. It's going to be negative infinity to infinity. And the asymptote is going to be x equals 2. Okay, that's it. That was kind of fun.